How ice cream is made. Ice cream is sold as hard ice cream or soft serve. After the freezing process, only a portion of the water is actually in a frozen state. Soft ice cream is served directly from the freezer, where only a small amount of the water has been frozen. Hard ice cream is packaged from the freezer and then goes through a hardening process that freezes more of the water in the mix. There is a wide range of ingredients and formulations that can be used in ice cream. Milk fat provides creaminess and richness to ice cream and contributes to its melting characteristics. The minimum fat content is 10%, and premium ice creams can contain as much as 16% milk fat. Sources of milk fat include milk, cream, and butter. The other milk solids consists of the protein and lactose in milk and ranges from 9 to 12% in ice cream. The non-fat solids play an important role in the body and texture of ice cream by stabilizing the air that is incorporated during the freezing process. Sources of non-fat solids include milk, cream, condensed milk, evaporated milk, dry milk, and whey. Sweeteners are used to provide the characteristic sweetness of ice cream. Sweeteners also lower the freezing point of the mix to allow some water to re-emin unfrozen at serving temperatures. A lower freezing point makes ice cream easier to scoop and eat, although the addition of too much sugar can make the product too soft. Sweeteners used include sugar and corn syrups. Stabilizers are proteins or carbohydrates used in ice cream to add viscosity and control ice crystallization. Over time, during frozen storage, small ice crystals naturally migrate together and form larger ice crystals. Stabilizers help to keep the small crystals isolated and prevent the growth of large crystals, which causes ice cream to be coarse, icy, and unpleasant to eat. Emulsifiers are used to help keep the milk fat evenly dispersed in the ice cream during freezing and storage. A good distribution of fat helps stabilize the air incorporated into the ice cream and provide a smooth product. A wide range of flavorings are used in ice cream. Flavorings include natural and artificial flavors, fruit, nuts, and bulky inclusions such as chocolate chunks and candies. General ice cream processing steps. Blend the ice cream mixture. The milk fat source, non-fat solids, stabilizers, and emulsifiers are blended to ensure complete mixing of liquid and dry ingredients. Ice cream mix is pasteurized for 30 minutes. The conditions used to pasteurize ice cream mix are greater than those used for fluid milk because of increased viscosity from the higher fat, solids, and sweetener content, and the addition of egg yolks in custard products. Homogenized ice cream mix is homogenized, 2,500 to 3,000 psi, to decrease the milk fat globule size to form a better emulsion and contribute to a smoother, creamier ice cream. Homogenization also ensures that the emulsifiers and stabilizers are well blended and evenly distributed in the ice cream mix before it is frozen. Age the mix. Ice cream mix is aged for at least 4 hours or overnight. Aging the mix cools it down before freezing, allows the milk fat to partially crystallize, and that gives the protein stabilizers time to hydrate. This improves the whipping properties of the mix. Add liquid flavors and colors. Liquid flavors and colors may be added to the mix before freezing. The process involves freezing the mix and incorporating air. Ice cream mix can be frozen in batch or continuous freezers, and the conditions used will depend on the type of freezer. Batch freezers consist of a rotating barrel that is usually filled 1/3 to 1/2 full with ice cream mix. As the barrel turns, the air in the barrel is incorporated into the ice cream mix. Continuous freezers consist of a fixed barrel that has a blade inside that constantly scrapes the surface of freezing barrel. The ice cream mix is pumped from a bulk tank to the freezing barrel, and the air is incorporated with another pump just before it enters the freezing barrel. The continuous freezing process is much faster than the batch freezing process. The addition of air is called overrun and contributes to the lightness or denseness of ice cream. Up to 50% of the volume of the finished ice cream, 100% overrun, can be air that is incorporated during freezing. The overrun level can be set as desired to adjust the denseness of the finished product. Premium ice creams have less overrun, approximately 80%, and are more dense than regular ice cream. At the point of discharge from the freezer, only about 50% of the water in ice cream is frozen. Soft serve ice cream is generated at this point in the freezing process. 7. Add fruits, nuts, and bulky flavorings. Fruits, swirls, and any bulky type of flavorings are added at this point. These ingredients cannot be added before freezing, or they would interfere with the smooth flow of the mix through the freezer. The ice cream at this point is soft, and it is easy to mix in the bulky flavorings, so they are uniformly distributed throughout the ice cream. Mixing in bulky flavorings after freezing also prevents damage to the pieces and allows them to remain whole or in large chunks. The ice cream is cooled as quickly as possible down to a holding temperature. The temperatures and times of cooling will depend on the type of storage freezer. Rapid cooling will promote quick freezing of water and create small ice crystals. Storage will help to stabilize the ice crystals and maintain product quality. At this temperature, there is still a small portion of liquid water. If all the water present in the ice cream were frozen, the ice cream would be as hard as an ice cube. When the ice cream comes out of the freezer, it isn't yet as hard as your ice cream in a tub. The exact temperature, though, will depend on the process. The ice cream will have to harden out further. This again has to be done efficiently and fast, so it is often done in a tunnel with blowing ice-cold air to rapidly remove the heat. To what extent the ice cream has to be cooled at this point really depends on the way it is processed further. If the ice cream still has to be shaped into all sorts of intricate forms, it will have to be hard enough to keep its shape, but soft enough to be shaped. On the other hand, if the ice cream is dosed in a tub, it will have to be flexible enough to still flatten out in the tub. After the ice cream has been put in its final packaging, it will continue to harden out. If you've made ice cream yourself, you will recognize that ice cream coming straight from the ice cream machine is still very soft and needs to harden out in the freezer.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.